Okay, in the last class, we discussed Schrodinger wave equation and its applications. Today, we will discuss important topic Schrodinger wave equation. Schrodinger wave equation. What is Schrodinger wave equation? Okay, the behavior of microscopic particles like electrons, protons and neutrons can be explained by Schrodinger wave equation. Schrodinger wave equation. So, dou square psi by, this equation is dou square psi by dou x square plus dou square psi by dou y square plus dou square psi divided by dou z square plus 4 pi square by lambda square into psi is equal to 0. Dou square psi by dou x square dou square psi by dou y square dou square psi by dou z square plus 4 pi square lambda square psi is equal to 0, where psi is equal to wave function, where psi is equal to wave function and x, y, z are coordinates. But 4 pi square divided by lambda square is equal to 4 pi square divided by h divided by p square. H square divided by p square. Since lambda is equal to h by p. Since lambda is equal to h by p. From this 4 pi square p square divided by h square. But p square is equal to yesterday I told you p square is equal to kinetic energy into 2 into mass. Therefore 4 pi square p square kinetic energy into 2 into m divided by h square, that is equal to 8 pi square m kinetic energy divided by h square. 8 pi square m kinetic energy divided by h square. Okay, next. So 4 pi square by lambda square is equal to 4 pi square divided by lambda square is equal to 8 pi square m kinetic energy divided by h square. But total energy is equal to kinetic energy plus potential energy. Therefore, kinetic energy is equal to total energy minus potential energy. Kinetic energy is equal to total energy minus potential energy. Therefore, kinetic energy is equal to total energy E, potential energy V. Therefore, 4 pi square divided by lambda square is equal to 8 pi square m. Okay, E minus V divided by h square. Substitute this value in the main equation. Dou square divided by dou square psi divided by dou x square plus dou square psi divided by dou y square plus dou square z divided by dou square psi divided by dou z square plus 8 pi square m into E minus V divided by h square into psi is equal to 0. This is the Schrodinger wave equation. Dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m E minus V divided by h square into psi is equal to 0, where psi is a wave function. Where psi is a wave function. Okay, m is mass of electron, h is Planck's constant, E is total energy, V is potential energy. V represents potential energy. Okay, psi is wave function. Though is partial differentiation. In mathematics teachers will tell you. Though differentiation, partial differentiation. Okay, next. Okay, for suppose here this is electron or any object. Okay, this object, it is denoted by xyz coordinate. Okay, this denoted by xyz coordinate. This is x-axis, this is y-axis, and this is z-axis. This is x-axis, this is y-axis, this is z-axis. This is radius r. This is angle theta. This is angle theta. This is angle theta. This is angle pi. So object, this object dot is denoted by xyz coordinate. Okay, write down xyz coordinate. It is also expressed with respect to with respect to polar coordinates. Polar coordinates are theta and pi. Okay, polar coordinates are theta and pi. Write down. R is equal to radius. Theta and pi is equal to angles. R is equal to radius, theta and pi is equal to angles. So psi means wave function. Psi, theta, pi angles. Psi wave function. So psi r theta pi is equal to psi r theta pi is equal to r. Okay, capital R and small r and a into theta pi. Okay, this is radial part. This is radial part. This is radial part. Okay, this is angular part. This is angular part. Okay, radial part is characterized by N and L. Radial part is characterized by N and L. N is principal quantum number. Principal quantum number, where L is azimuthal quantum number. Azimuthal quantum number. Okay, angular part is characterized by Lm. Angular part is characterized by Lm. L is azimuthal quantum number. In 10th class already you read. Okay, M is magnetic quantum number. M is magnetic quantum number. M is a magnetic quantum number. Okay. R square is R. What is R? Radial part of wave function. What is R? Radial part of wave function. R is equal to radial part of wave function. Wave function. R is equal to radial part of wave function. R square is equal to radial probability density. Radial probability density. Radial probability density. Okay, now A square is equal to angular probability density. A square is equal to angular probability density. Angular probability density. So, when Schrodinger wave equation is solved, a series of solutions are formed. Each solution is denoted by psi. So, each solution is denoted by psi. So, when wave equation, though x square plus 8 pi square m divided by h square psi is equal to 0. Solved. A series of solutions are applied. A series of solutions are applied. A series of solutions are applied. Each solution is called wave function. Wave function is denoted by psi. Okay. So psi gives all the information about electron. Psi gives all the information about electron. Similarly, when Schrodinger wave equation is solved, 3 quantum numbers are obtained. principal quantum number, azimuthal quantum number, and magnetic quantum number. When Schrodinger wave equation is solved, three quantum numbers are obtained: principal quantum number, azimuthal quantum number, and magnetic quantum number, but not spin quantum number. So when Schrodinger wave equation is solved, three quantum numbers are obtained. So according to Heisenberg, existence of orbits are ruled out. According to Heisenberg, existence of orbits are ruled out. So he introduced orbital instead of orbit. He introduced the word orbital instead of orbit. What is the difference between orbit and orbital? Orbit is a path in which electron is revolved around the nucleus. But orbital is a small region where the probability of finding an electron is maximum around the nucleus. So orbital is characterized by three quantum numbers: principal quantum number, azimuthal quantum number, and magnetic quantum number. So from de Broglie concept onwards, you have to replace orbits and introduce the orbitals. Okay. Tomorrow we will discuss quantum numbers and shapes of orbitals. Quantum numbers. Yesterday you discussed Schrodinger wave equation. When Schrodinger wave equation is solved, three quantum numbers are obtained: principal quantum number, azimuthal quantum number, and magnetic quantum number. Numbers which can determine position of an electron into atom. Numbers which can determine position of an electron in an atom. Numbers which can determine position of an electron in an atom. Okay, N, L, M come from N, L, M are come from wave equation. Wave equation. Okay, atom contain orbit or shell. Okay, shell contains, orbit contains subshell. Subshell contains orbitals. Orbitals contain electrons. So an orbital is characterized by three quantum numbers n, l, m. An orbital is characterized by three quantum numbers n, l, m. But the position of electron, the entire picture of electron is characterized by four quantum numbers. Principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Covered numbers which can determine position of an electron into atom. These are principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. So an orbital is characterized by three quantum numbers only, n, l, m. An electron is characterized by four quantum numbers, n, l, m and s. First one, principal quantum number. Principal quantum number. Principal quantum number. Principal quantum number. It is denoted by n. It is denoted by n. N takes from 1 to infinity. 1 to infinity. N determines energy and size of orbital. Next, energy of orbital is directly proportional to n. Size of orbital is directly proportional to n. Size of orbital is also directly proportional to n. Okay, now maximum number of orbitals is equal to n square. Maximum number of orbitals is equal to n square. Maximum number of electrons in a given orbit is equal to 2n square. Maximum number of electrons present in a given orbit is equal to 2n square. This is a principal quantum number. Angular momentum is equal to MVR is equal to NH divided by 2 pi. Angular momentum MVR is equal to NH divided by 2 pi. Where N is equal to first orbit, second orbit, third orbit, 1, 2, 3, 4 integer. H is equal to Planck's constant. Okay, MVR is equal to angular momentum. This is the principal quantum number. For suppose n value, number of orbitals, number of electrons, maximum number of electrons. If n is equal to 1, number of orbitals 1, number of electrons 2. If n is equal to 2, number of orbitals 4. Number of orbitals is equal to n square. Number of orbitals is equal to n square. Okay, therefore number of electrons is equal to 2n square. Number of electrons is equal to 2n square. That is equal to 8. N is equal to 3. Number of orbitals 9. Number of electrons 18. If n is equal to 4, number of orbitals 16. Number of electrons 32. If n is equal to 5, number of orbitals 25. Number of electrons 50. Number of electrons 50. Okay. This is principal quantum number. So, principal quantum number determines energy and shape of a orbital. Next, azimuthal quantum number. Second one, azimuthal quantum number. Azimuthal quantum number. It is denoted by L. L depends on N. L takes 0 to n minus 1. L takes 0 to n minus 1. Okay, when n is equal to 1, L is equal to 0, S subshell. Okay, when n is equal to 2, L is equal to 0, 1, 2S subshell and 2P subshell. Okay, when n is equal to 3, L is equal to 0, 1, 2, 3S, 3P and 3D subshells. 3S, 3P and 3D subshells. When n is equal to 4, L is equal to 0, 1, 2, 3, 4S, 4P, 4T, 4F subshells. 4F subshells. Okay, so azimuthal quantum number determines type of the subshell. Okay, azimuthal quantum number also determines energy of the orbital. So, energy of orbital is determined by both principal quantum number and azimuthal quantum number, n plus L value. Okay, so azimuthal quantum number determines type of orbital or type of subshell. Azimuthal quantum number determines type of subshell. Next, number of subshells is equal to number of electrons in a given subshell. In a given subshell is equal to 2 into 2L plus 1. 2 into number of electrons in a given subshell is equal to 2 into 2L plus 1. This is S subshell. Number of electrons 2 into 0 plus 1, that is equal to 2 electrons. This is P subshell. 2 into 1 plus 1, that is equal to 6 electrons. D subshell. 2 into 2 plus 1, that is equal to 10 electrons. F subshell. 2 into 2 plus 1, that is equal to 14 electrons. 2 into 3 plus 1. So for S orbital, F subshell, P subshell, D subshell, F subshell, L is equal to 0, 1, 2, 3. 0, 1, 2, 3. Okay, this is azimuthal quantum number. Next, orbital angular momentum is equal to orbital angular momentum is equal to orbital angular momentum is equal to root of L into L plus 1 h divided by 2 pi. Root of L into L plus 1 into h divided by 2 pi. This is azimuthal quantum number. And the next third one is magnetic quantum number. Magnetic quantum number. Magnetic quantum number. First one, it is denoted by M. M value depends on L. M takes minus L to plus L, including 0. Okay. M determines orientation of orbitals. Number of orientations is equal to 2L plus 1. Okay. Number of orientations is equal to 2L plus 1. Okay, next. For example, S sub shell. Number of orientations. 2 into 2L plus 1. 0 plus 1. That is equal to 1. So for S sub shell, number of orientations 1. So S sub shell has only one room. Only one orbital. S sub shell has only one room. Okay. P sub shell. Number of orientations is equal to 2 into 1 plus 1, that is equal to 3. So P sub shell consists of 3 rooms. These are 3 P orbitals. These are 3 P orbitals. Px, Py and Pz. Number of orientations 3. So when L is equal to 0, M is equal to 0, S orbital. L is equal to 1, M is equal to minus 1, 0, plus 1. So 3 P orbitals, Px, Py, Pz orbitals. When L is equal to 2, M is equal to minus 2, minus 1, 0, plus 1, plus 2. There are 5 D orbitals. There are 5 D orbitals. There are 5 D orbitals. Minus 2, minus 1, 0, plus 1, plus 2. dxy, dyz, dz square, dxy, dx square minus y square. There are 5 d orbitals. This is magnetic quantum number. Magnetic quantum number determines orientation of the orbitals. Orientation of the orbitals. And the last one, spin quantum number. Spin quantum number. Spin quantum number. Okay, this is denoted by yes. So an orbital has maximum of two electrons. Okay, one has clockwise direction and another has anti-clockwise direction. For clockwise direction, S is equal to plus half. For anti-clockwise direction, S is equal to minus half. For suppose sodium 1s2, 2s2, 2p6, 3s1. What are the four quantum numbers for differentiating electron of sodium? The electronic configuration of sodium is the valence shell electronic configuration of sodium is 3s1. Therefore, n is equal to 3, L is equal to 0 for s subshell, m is equal to 0, s is equal to plus half. Okay. What are the four quantum numbers for? Differentiating electron of oxygen atom? Oxygen, atomic number 8, 1s2, 2s2, 2p6, 2p4. So 1s2, 2s2 and 2p4. 1, 2, 3, 4. First electron, second electron, third electron, fourth electron, fifth electron, sixth electron, seventh electron, eighth electron. N is equal to 2. L is equal to minus 1. L is equal to L is equal to 1. M is equal to minus 1 or 0 or plus 1. S is equal to minus half. Okay, these are the four quantum numbers. So the position of electron and the picture of electron can be determined by using four quantum numbers. This is the class 10. Okay.